Somewhere in a rainforest right now, an ant is climbing. It should not be climbing. It is a worker ant, and its job is on the forest floor, following scent trails, carrying food, serving the colony. But today it has left the trail. It is climbing a plant it has no reason to climb, moving with a strange, jerky determination, as if something else is steering. It climbs to a very specific height. It turns to face a very specific direction. And then, at solar noon, it does something no healthy ant would ever do. It bites down into the vein on the underside of a leaf, and it locks its jaws there, and it waits to die. The ant is not sick. The ant is not lost. The ant is being driven, like a car with someone else behind the wheel. And the driver is a fungus that has already, quietly, replaced almost half of the creature's body from the inside. This is not a horror movie. This is one of the most studied, most astonishing relationships in all of biology. And by the end of this video, you'll understand not just how it works, but why the truth is even stranger than the legend. Because for years, even the scientists got the most important part wrong. Let me introduce the puppet master. Its name is Ophiocordyceps unilateralis. It belongs to a huge family of parasitic fungi, and this particular branch has one specialty: carpenter ants. It was first noticed by a Western scientist back in 1859 by the British naturalist Alfred Russel Wallace, the same man who arrived at the theory of evolution by natural selection at the same time as Charles Darwin. Wallace was exploring the tropics when he saw ants that had died in bizarre, unnatural poses, with strange stalks growing out of their bodies. He had stumbled onto a phenomenon that would take another century and a half to truly understand. Here is what makes this fungus special, and what separates it from the cartoon version most people carry in their heads. Ophiocordyceps does not grow on the ant. It grows inside the ant. When a single microscopic spore lands on the ant's outer shell, it doesn't just sit there. It germinates, and it drills. The fungus produces enzymes that break down the tough outer armor of the insect, the exoskeleton made of a material called chitin, and it slips inside the body. Once in, it begins to feed and to multiply, spreading through the ant not as a lump, but as a web. Thread-like fungal cells push through the spaces between the ant's own tissues, growing, branching, connecting to each other. Now here is the number that should stop you. When researchers at Penn State University cut infected ants into microscopically thin slices and used artificial intelligence to tell fungal cells apart from ant cells, they discovered that in a fully manipulated ant, an enormous proportion of everything inside the body was no longer ant. It was fungus. The lead researcher put it in a way that is hard to forget. These manipulated animals, he said, were essentially a fungus in an ant's clothing. The ant was still walking, still moving, still alive. But most of what was carrying out that movement had been replaced. So the fungus is inside. It has taken over the body. And now comes the part that everyone gets wrong. For decades, the story was simple and satisfying. The fungus infects the brain and controls the ant's mind. It made sense. We are creatures who think of the brain as the seat of control, so of course a mind control parasite would seize the brain. It was in documentaries. It was in textbooks. It inspired video games and television shows watched by millions. And it was wrong. When those same researchers went looking for fungal cells inside the ant's brain, expecting to find the parasite wrapped around the control center, they found nothing. The brain was clean, untouched, intact. The fungus had colonized the head, the thorax, the abdomen, the legs. It was everywhere in the body, but it had deliberately left the one organ we assumed it needed completely alone. So how does it steer the ant? The answer rewrites what we thought was even possible. Instead of hijacking the brain, the fungus wraps itself directly around the ant's muscle fibers. It forms a three-dimensional network of fungal cells threaded through the muscles, and this network appears to act together, contracting and controlling the ant's body from the outside of the cells, bypassing the brain entirely. In a healthy animal, the brain sends the signal and the muscle obeys. In a manipulated ant, the fungus has cut out the middleman. It moves the legs itself. The ant, disturbingly, may remain conscious the whole time, a passenger locked inside a body that no longer takes its orders. The final act is the death grip. When the moment comes, the fungus forces the muscles of the ant's jaw into a violent, permanent contraction. Scientists who studied these jaw muscles found them hypercontracted, clamped shut so hard the ant can never release. This is why the ant bites down and stays biting, even in death. It has been anchored in place on purpose. And the placement is not random. It is engineered. The fungus drives the ant to a precise microclimate, often around 25 centimeters above the forest floor, on the underside of a leaf, in the humidity and temperature that the fungus needs to grow. It even controls the timing, driving the ant to make its final bite around noon. The infected ants are so consistent in the height and direction they choose that researchers suspect the fungus is manipulating something like the ant's internal compass, its sense of where it is in space. Then the ant dies, and the fungus, finally free to feed without restraint, consumes what is left of the body from the inside. A few days later, a stalk erupts from the back of the dead ant's head, growing up and out like an antenna. From the tip of that stalk, the fungus releases a rain of new spores, drifting down onto the forest floor exactly where other ants travel. The trap is reset. The cycle begins again. Now let me show you the part of this story that turns everything upside down. Because the same fungus that inspires horror has also been treasured by human beings for centuries as one of the most precious substances on Earth. High in the mountains of Tibet and the Himalayas, above 3,000 meters, there lives a cousin of our zombie fungus. Instead of ants, it infects the underground caterpillars of ghost moths. It does the same terrible thing, filling the caterpillar's body with fungal threads, mummifying it, and then in spring sending a single blade-like stalk up out of the dead caterpillar's head into the sunlight. The people of the Tibetan Plateau have known this creature for a very long time. Its name was first written down in the 15th century by a Tibetan doctor in a medical text with the unforgettable title and ocean of aphrodisiacal qualities. In Tibetan, it is called Yartsa Gunbu, which means summer grass, winter worm, because in winter it seems to be an animal buried in the ground, and in summer it appears to be a plant reaching for the sky. Part animal, part plant, part neither. A thing that broke the categories people used to sort the living world. For centuries, it was a remedy reserved for the wealthy and powerful, offered to emperors, prized as a tonic for long life, strength, and vitality. Traditional healers used it for dozens of ailments, from exhaustion to illness of the lungs and kidneys. But it is what happened to this fungus in modern times that is truly staggering. As China's economy boomed and a new middle class went looking for status symbols, demand for the caterpillar fungus exploded. And because it cannot be easily farmed, because each one must still be dug by hand out of remote alpine meadows, the supply could not keep up. The price climbed, and then went vertical. In the early 2000s, a kilogram sold for around $3,000. Within about 15 years, top-quality caterpillar fungus was selling for $30,000, $40,000, and by some accounts over $100,000 per kilogram. It became worth more than its weight in gold. In China, they gave it a nickname that captures exactly what it had become: soft gold. Think about what that means. In the remote villages of the plateau, this single fungus became the largest source of cash income for entire communities, in some years contributing the overwhelming majority of a household's annual earnings. A businessman wanting to flaunt his wealth would not open an expensive bottle of wine. He would serve a duck stuffed with $1,000 worth of mummified caterpillar. And where there is that much money buried in the ground, there is also conflict. The harvest has been shadowed by disputes, by territory closed off to outsiders each spring, and even by violence and death over access to the richest meadows. So the very same kind of fungus that we film for horror documentaries is, on the other side of the world, dug reverently out of the mountains and sold for more than platinum. Killer and treasure in the same organism. Which brings us to the question you might be asking with a small knot in your stomach. Could it ever happen to us? Could a fungus like this take over a human being? The honest answer is the reassuring one. No. Ophiocordyceps evolved over millions of years to exploit the specific body of a specific insect, one that lives at temperatures far cooler than ours. Our warm bodies are a hostile furnace to it. The mind control it performs is exquisitely tuned to the ant, so precisely that a given strain often manipulates only one species of ant and merely kills the others without steering them at all. The apocalyptic version you have seen on screen, where the fungus jumps to humans and ends civilization, is fiction built on a real foundation, and the fiction stops exactly where the biology begins. But here is the twist that closes the circle. Scientists are not studying this fungus only to fear it. They are studying it because they want what it makes. To manipulate the ant so precisely, the fungus secretes a cocktail of powerful bioactive compounds, molecules tuned to interfere with the nervous system. When researchers analyzed what the fungus produces, they found candidate compounds already known to science for their links to neurological conditions. And the caterpillar fungus, the soft gold of Tibet, has been found to contain a wide array of compounds studied for effects on the immune system, on inflammation, and in cancer research. Let that settle for a moment. The same chemical genius that lets this fungus reach into a living creature and take the controls is exactly what makes it interesting to medicine. The thing that kills the ant may hold, somewhere in its molecules, something that heals a human. That is the real lesson hidden in the story of the puppet master. We look at this fungus and we see a monster, because it does something that violates our deepest instinct about who owns a body. But nature does not deal in monsters and heroes. It deals in survival, and in chemistry, and in relationships so old and so intricate that we are still, after 160 years, only beginning to read them. A creature that turns an ant into a puppet is also a pharmacy we have barely opened. So the next time you walk through a forest, remember what is happening beneath the leaves you pass. Remember that under the quiet green, invisible wars are being fought and won with weapons made of chemistry, and that some of the most ancient intelligence on this planet has no brain at all. In the next hidden history, we'll meet a fungus that doesn't need to take over your body to kill you. One that looks completely harmless, that has been mistaken for a meal at countless dinner tables, and that has quietly ended the lives of emperors and kings. The death cap. If you want to keep exploring the hidden world beneath our feet, subscribe, and I'll see you in the next one.